Hey guys, I hope you're doing well. This is JSer, who is not good at algorithms. I'm recording this video to prepare my Facebook interview next month. In this video, I'm going to take a look at 680, valid palindrome 2. We're given a non-empty string S. We may delete at most one character, so 0 or 1 character. Judge whether we can make it a palindrome. Palindrome. ABA. Yeah, of course, we don't need to remove anything. True. ABCA. True. So we could delete C. Well, let's just analyze what the palindrome means. It means we can read it forward or backward. It was just the same, right? ABA, or from this direction, ABA. Well, this just we could solve it with recursion, I think, because if it is a valid palindrome, then the head and tail should be the same. So we could just remove them, right? And remove them, it becomes a recursion problem of the substring. If it is not the same, like BC, we could delete at most one character. So maybe we could delete this one, and or delete this one. So it's a recursion problem. Let's try to do it. So it's create a check. Well, we received only one string, so we use the start and end to mark our iteration. If S, if start is bigger or equal to end, wait a minute. Yeah, then we return true, right? It's valid. Or if S start equals Sn, then we return check start plus 1 and minus 1. If they are not the same, then we could it's counted. Siri doesn't look well. Removals equals 1. I say if we could remove it. Wait a minute. We should, for each iteration, we need to pass the removals. Max removals. Max removal. What the fuck? Sorry about the earphone. Is bigger than 0, so we can remove one. Then we return if check start 1, remove the left start, return true. Or we return the end 1, right? If they are different and there's no removal, we can do return false. So at last we return check 0 s.length minus 1, 1, right? I think this should work. Cool. False. Shit. Okay, for A, B, C, A, they are the same. I forgot to pass the max removals. Shit. Why would we return true? Forgive me, Lord. I need to delete one because we already used one. Yeah. Cool. We're accepted, but only faster than 27%. Could we do better? So could we do better? Could we do better? So what's the time complexity of this one? Well, every time we at least remove one element, right? For these, we still remove one element. We only have, if we think of it as a tree, there will be only 2 children for once. So maximum it would be linear time. So for this, I think it's still linear time. Now let's try to improve it. So how could we improve it? Well, there's a, if it is this palindrome, if we pick the center and expand it from to the left and to the right, we compare them. So for this is an odd number, so B, we can ignore it and expand, right? If we made something different, we could remove it. If we remove it, the center changes. It changes here or here. Wow. So yeah, if we, like say, if we remove a character anywhere for these 4, for this string, the center will be here, right? Between B and C. If we remove A, it will be C. If we remove C or A, it will be B. So we can do it better maybe without recursion. We could choose the center, at most 1 character, so there will be at most 3 centers, and we can do expansion like that. And we could, if we choose center here, we could ignore 1 element, right? Means I could remove B. If B, remove B, remove the first thing that is not, remove the first thing, first letter that is not matched. Cool. So our next solution would be choose the center, expand 2 ways to compare, right? Remove a number, remove a character. Removal of a character could only be on the left or on the right. So it would be actually O3n. Right? Yeah, let's try to do it. First, without without removal of anything, the center would be 4. So it should be this would be 1. And 3, it should be 1. So -1. So if S is odd number, is even number, let center start left, start right. If it's even number, then start left equals start length divided by 2 minus 1. Start right equals this. For the other case, start left equals start start length minus 1 divided by 2. Start right equals start left. Right? Okay. So while start left is bigger than 0, let's if s star left is not equal to, then break. Right? If they are the same, start left, start right. Okay. So is valid equals start left equals -1. If it is valid, we return true. Now, it is not valid. Let's try to remove a number. Well, we will do the same. So it would be so let's start remove. If we remove at left half, like remove left half, then the center would be this one, right? So we copy. Okay, I'll move this. Let's do it again. If it's an even number, remove the left half, then the start and left would be like this. So it would be, okay, this. Right would be start left. If it is odd, remove something to the left, then the center would be start left would not change. It's still here. But the start right would not. Start right would be +1. Cool. Now let's start. Because we move at the left half, the left half will end faster, right? Yeah, when it's like this, if they're not the same, we we still need to keep track of the removal. Let removal count equals 1. If remove 1 is more than 1, we break, so there's no chance, right? For the other case, we could use removal, and then we will start left minus 1. Because remove it. But the right, we need to keep it minus, I've subtracted with 1 so that it will keep the same, right? And then we say if star left could go to minus 1, we return true. Now this will keep doing. Now let's try to say if we move at right half, if it is even number, we move here, it would be left would be, yeah, minus 1. Start right would be yeah, start left. If it is odd, remove it, so it would be here. And this would be minus 1 again. Subtract with 1, 3, 1, 0. This one start at plus 1. Okay, so this will be checking right. While we start smaller than x dot then. If start doesn't meet, start left would, all start left would be plus 1, I think, to keep it the same. Right, actually, we'll remove 1. And so, and if right, start right is now put to this, return true, and return false. Oh, this actually is not very beautiful. Huh? Start right plus 1. Okay. Removal count has been declared. ABC. We return true. Why? It should be false. Remove left BC. Ah. BC doesn't match, so we remove B. It should go to A. Ah, but we subtract another one. Oh. Oh, God, we should not do this. Ah, yeah, this is remove right. Yeah. Ah, my bad. I'm so stupid. Cool. Now we are faster, but this is really not very. This is really not very beautiful. Could we improve the code? Improve it better? Like actually, these three could actually be merged into one. No. This is +1. This is -1. Could we do it better? We are faster. So this is linear time. Space, nothing special, so constant. And this actually could be merged into one, right? So I'll create another const check. We mean start left, start left, start right. Ah, this doesn't matter actually. We could with removal, right? Max removal, and yeah, we just say wow. Removal right or removal left, it's different. Max removal left, okay, max removal right. No. Removal 0 or -1 left, or 1 means right. Okay, remove right. So while start is this, if it's not it's different, so if it's 0 we break, return false, and then removal, if remove left, I mean remove +1. and if we move right left, so start right, divide minus by 1. Okay, so start. Okay, this is the same. And finally, if nothing happens, we return true, right? If we move or smaller than 0, else then it must be bigger than 0, right? Removal divided by 1. Start left plus 1. Okay, now we check. So we could remove this, and the if check start left, start right, 0. And again, it would be minus 1. This is looks cleaner. Cool. This is cleaner. Could we do better? If we could move at left half. So if we from left half from the original, it would be plus 1, and this one would be the same. Start right, plus 1. Oh no. Start right doesn't change. Start right minus 1. For here, start left doesn't change. Start right minus 1. Here, start left minus 1. Start right doesn't change, right? So the original start left, we will just do actually start left plus 1. This start left doesn't change. Start left minus 1. Start left minus 1. Start this is chaos. Could we do better? Let's take a look at the solution. To force greedy. By Palindrome at range, okay, for it's true. So if it is, return this with this. Hmm? This could be better than us? Ah, God. Wow, I think this is actually good, but it's chaos, the code. We should return back to our recursion here. The same, we check the previous one. If max removal bigger than 0, we remove 1. Ho ho ho. This seems why this is slow? Why this is slow? It is not slow, man. It just I think yeah, this one actually is the same as the time complexity is the same as this one. The solution here. No, this one. This solution here. So it's just we don't check both the ends. We check one. If it's true, we return. We check the next one. So cool. This seems good. Actually, but this is garbage. Please ignore that. Wow, recursion. Yeah, recursion is the king. Okay, hope it helps. See you next time. Bye bye.